These are questions 24 and 25 from the Unit 3 review. For each function, find the axis of symmetry, find the vertex, make a table, and graph the function. These are written in standard form, and because they're written in standard form, we have to do a little bit more work in order to find the axis or to find the vertex. We have to find the axis of symmetry before we can find the vertex when a problem is written in standard form. So we want to identify our A, our B, and our C before we even start. A is a positive 1, B is a positive 6, and C is also positive 1. So we're going to plug the numbers that we need, the A and the B, into the axis of symmetry formula. X equals negative 1 times B. So we're going to take the B out and replace it with a 6. And on the bottom we have 2 times A. We're going to take the A out and replace it with a 1. Negative 1 times 6 is negative 6. 2 times 1 is 2. And then we're going to reduce. Negative 6 divided by 2 is negative 3. So our axis of symmetry is negative 3. To find the y so that we can write down our vertex, we're going to go back to the original problem. We're going to take the x's out and we're going to replace them with a negative 3. So we take the x out and put in a pair of parentheses and a negative 3. And our first x gets squared. Plus 6 times parentheses, and we're going to put that negative 3 in there, plus 1. And all of those things, when you add them together, y will equal negative 8. So that means our vertex is negative 3, negative 8. And then we're going to do like we did in questions 22 and 23. We're going to take this vertex and we're going to make a table, and then we're going to graph the problem. So I'm going to write the equation over here one more time. Y equals x squared plus 6x plus 1. So our vertex was negative 3, negative 8. And we're going to use our calculator to make this table. So we're going to go to y equals, clear out anything that's in y equals. And this was my original function. So I'm going to say x squared plus 6x plus 1. And I want to look at the table, so I do second graph. And there's my table, and I said the vertex was negative 3, negative 8. And if you look in the y, you can see in the y column, the numbers start to repeat, and they have the same pattern on the top side of the vertex as they do on the bottom side of the vertex. So we're going to do two numbers smaller than negative 3. So we're going to do negative 4 and negative 5. And we're going to do two numbers bigger, so we're going to do negative 2 and negative 1. When x is negative 5, y is negative 4. When x is negative 4, y is negative 7. There's our negative 3, negative 8. When x is negative 2, y is negative 7. And when x is negative 1, y is negative 4. And we're going to graph those points. We've got the pattern that we know we should have to create a parabola. We've got a center, and we've got numbers on either side that are the same. So we're going to go to the left 5 spaces. We're going to go down 1, 2, 3, 4 spaces. We're going to go to the left 4 spaces, and we're going to go down 1, 2, 3, 4, 5, 6, 7 spaces. Then we're going to go to the left 3 spaces and down 8 spaces. We're going to go to the left 2 spaces and down 7 spaces, and then 1 and negative 4 again. This should open up because our A term is still a positive term, so it should open up. And we connect our points as neatly as we can. Number 25, let's go ahead and label our A and our B and our C. So A, B, and C. A is always stuck to the x squared. Even though you don't see a number there, there is a negative there, so that's a negative 1 for A. B is always stuck to an x. There is no just x in here with a coefficient. If there's no x with a coefficient, then our B is 0. And then this constant, this number standing here alone, is our C term. And we're going to plug those in. So x equals negative 1 times B. over 2 times a. So that's 0 divided by negative 2, which equals 0. So our axis of symmetry is 0. And we're going to take that axis of symmetry and we're going to plug it back in to the original problem. So we're going to put that y equals, we're going to put a negative symbol. We're going to take the x out, we're going to put a 0 in those parentheses, and we're going to square it, and we're going to add 4. Well, 0 squared is just 0. There's no such thing as a negative 0. And 0 plus 4 means that y equals 4. So my vertex is this x and this y written as a coordinate pair. So 0, positive 4. And we're going to take that vertex and our original function and we're going to make a table in our calculator. So I'm going to write the problem down again. Y equals negative x squared plus 4. And then we're going to slide down here and we're going to make a table with that 0 and that 4 in the center of it. So we take our calculator, we go to y equals, and in our calculator we type negative x squared plus 4, and we look at the table. So our vertex was at 0, and if you look in the y, you can see the pattern repeating to the top and repeating to the bottom. So we're going to go 2 numbers smaller and 2 numbers bigger than 0. So we're going to go negative 1, negative 2, positive 1, positive 2. On the table, when we're at negative 2 in the x column, our y is 0. And when we're at negative 1 in the x column, our y is 3. And then there's our vertex again. When we're positive 1 in the x column, we're at positive 3 in the y column. And when we're at positive 2 in the x column, we're at 0 again in the y column. So let's take these ordered pairs and let's graph them. The first one tells me to go to the left 2 places, and then because my y is 0, I just stay right there. Then my next point is negative 1, so I go to the left 1 place, and then I go up 1, 2, 3 places. My vertex says don't go left or right because my first number is a 0, and then go up 4 spaces, so 1, 2, 3, 4. My fourth point goes to the right 1 place and goes up 3. And my fifth point goes to the right 2 places and it doesn't go anywhere else. It stays on the x-axis. So this a term was a negative term, so that tells us that our parabola is going to turn upside down from the parent function. And we're just going to very carefully connect our points to make the best U shape that we can and put those arrows on the end of it.